Staging, written and presented by me, Jean Leguay. Here's the legal stuff. Let's look at a couple of different examples of staging. In the first example, we have to maintain a certain pressure in a header. We need to start pumps up in sequence until the target pressure is reached. There's 4 possible stages: 1 pump running, 2 pumps running, 3 pumps running, and 4 pumps running. Rather than jump straight into programming, I'm going to flesh it out as a sequence of operations, kind of a pseudo program. If I had a program that would stage up to maintain header pressure, and it started the pumps in sequence, say A, B, C, D, that would work fine. However, there'd be a problem with runtime, just like in the duty standby example. Pump A would wear out, and pump D would seize up from never being used. To even out pump usage, I need to start them in different sequences each day. I'll need to find a convenient time to change sequences. Like I said before, I normally pick midnight because it's quiet time. So on day 0, I'll start them up A, B, C, D. On day 1, B, C, D, A. On day 2, C, D, A, B. And on day 3, D, A, B, C. This way, all the pumps would get equal use. So it looks like I've got 2 problems to solve. Firstly, the staging itself, and secondly, the sequencing. For staging, my personal favourite way of doing this is to reproduce what we used to do in the past. We used to use cam timers. I know that people say you should use PID, but from my experience, PID has a tendency to oscillate and overshoot, and that makes it entirely unsuitable. Technically speaking, the cam timer is a pure integral control. The PLC equivalent of a cam timer is a counter. The Zelio actually has something called a cam, but it's not that. I want the counter to count up if the pressure's too low, less than set point. I also want a dead band. That's an area where we deem it's close enough so don't do anything. Let's take an example. The set point is 50 with a dead band of 10. We increase the timer if the pressure is below 45. That's half of the dead band. And we decrease it if the pressure is above 55. That's set point plus half dead band. I want the counter to count down if the pressure is too high, more than set point plus half dead point band. Counters count pulses. So I need to change the too high and the too low signals into pulses. I change the signals using pulsing bistable counters, set to give 1 second pulses. Something to consider. What do you want the pumps to do after a power failure? Do you want them to continue where they were before the power failure or to start back up? If we suddenly start 4 big pumps, there's a good chance we'll blow the overloads because of the inrush. Now, I need to decide what value to use to trigger the stages, and also the maximum that the counter should be limited to. To find these values, I first determine the minimum delay between stages in seconds. Let's say that the customer wants a delay of 10 minutes between stages. That's 600 seconds. So I trigger a new stage every 600 seconds. The maximum the counter should go to is 600 times 4, which is 2,400. And the minimum, of course, is 0. The table shows the on and off values for each stage. I'll probably implement it using 2 position control blocks. I'll also put in some traps to stop the counter counting up too high or below 0. They're just small details. Here I've put in the 2 position controls and the traps. That's staging pretty well sorted out. I'll leave it up for a couple of seconds. Before we sort out the sequencing, we need to generate a day number from 0 to 3. I'll leave it to you to figure this out. It's on the final program. The only important thing is that the day number needs to be converted into its binary form. In other words, 0 goes 0, 0, 1, 0, 1, 2 would be 1, 0, and 3 would be 1, 1. To sort out the sequencing, we return to the fundamentals of programming, and we write a sentence explaining when the output comes on. So pump A comes on when day 0 and stage 1, or day 1 and stage 4, or day 2, stage 3, or day 3 and stage 2. Writing this out, then we just get this sentence. Now I'll just add the other pumps. That's pump B, pump C, and pump D. Ands and ors, well, that's just logic. I hope you can see how this could be adapted for the rest of the pumps. From now on, it's just a case of slogging away and actually producing the program. Here's the program written for the Zelio PLC. I'd probably clean it up using macros, but I wanted you to see all of the workings. This can easily be adapted to any other PLC. Right, let's have a look at the other type of staging, the staging that we might do with chillers or boilers. Now, a chiller is a refrigerator. It's a machine that pumps heat from one place to the next. In the case of a chiller, it's used to chill water. The water in this bit, called the evaporator, gets cold. The water in this bit, called the condenser, gets hot. This is a compressor that pumps the fridge gas around. In my example, I've got 3 chillers. The chilled water pump pumps water through the chillers, which cools the water. The chilled water is sent off to the building or the plant. We need to maintain a certain chilled water supply temperature. We need to get rid of the heat that builds up in the condensers. The condenser water is pumped to the cooling tower where it's cooled and then returned. Here's the complete system with chilled and condenser water. In my example, 2 of the chillers, chillers A and B, have the same capacity in kilowatts, and the third chiller, chiller C, is larger. Staging means running the correct combination of chillers in order to maintain chilled water supply temperature. First thing I do is I calculate the maximum and minimum capacities of every combination of chillers. Then I graph the values for the combinations. Before I start creating the stages, I'd just like to say that often just starting up the chill water pump is enough. That's all it takes to provide the chilling that we need. So more often than not, I use the chill water pump on as the first stage of cooling. Then from the graph, I choose my stages. I like to have an overlap, and I prefer to only switch one chiller at a time. So I've chosen my stages like this. From the graph then, I build a table of what each stage represents, what chiller will be on, and the maximum and minimum capacities of that stage. I add a stage 0, which is no cooling at all. Oh, and I turn the table over to match the one we had with the pumps. As I said before, I like to have an overlap. Sometimes there's no overlap, such as here or here. I need to fix that. To fix it, I add 20-ish% to the maximum of the lower stage. In this case, I changed stage 0 max from 0 to 20. And I changed stage 1 max from 100 to 120. Now I've got a little bit of an overlap. Now I put in the on and off thresholds for each stage. I choose the on threshold by making it the maximum of the previous stage, and the off threshold is the minimum of the current stage. The structure of the program is going to be very similar to the previous one. We've got the on-off values. I'll leave it to you to fill in all the details. I'd probably put in something that would allow a chiller to run as a stand-in case of failure. In other words, if chiller A fails, I'll run chiller B instead. But it's all just details from now on. And that's it for staging. In fact, that's it for the course.